All right, let's do our last example. Francisco and Navraj drive away from an intersection. Francisco travels south at a constant rate of 60 miles per hour, and Navraj travels west at a constant rate of 25 miles per hour. At what rate is the distance between the two changing 2 hours after they start driving? So they gave us some rates. They said Francisco is driving south at a constant rate of 60 miles per hour, and Navraj is traveling west at a constant rate of 25 miles per hour. And then they asked us to find this rate of change. At what rate is the distance between them changing at a particular moment 2 hours after they start driving? So I'm going to do a little diagram because it's fun for me and helpful. We've got our intersection. And Francisco is traveling south. Here's his little car, his little buggy. And Navraj is traveling west. Here's his little buggy. And we're trying to figure out, that's supposed to be a straight line, we're trying to figure out the rate at which that distance between them is changing over time. Notice that that's a right angle. I'm going to go ahead and let n be the distance that Navraj has traveled, f be the distance that Francisco is traveled, and then d being the distance between the two of them. And let's identify the given rates and the unknown rates. So given, Francisco is traveling at a constant rate of 60 miles per hour. That means that the distance that he has traveled is increasing, right? This distance is positive, distance is positive, but this distance keeps getting longer and longer the more more time passes, because he's driving more in the same direction. So the rate at which the distance that he has traveled is changing with respect to time is positive 60 miles per 1 hour. And again, this is positive because his distance is increasing. The distance he's traveled is increasing over time. I'm just going to write with time. All right, we're also given that Navraj is traveling at a constant rate of 25 miles per hour. That means that the distance and that he has traveled is increasing at this constant rate of 25 miles every hour. dn dt, or if you want n prime, is going to be, again, positive 25 miles for every 1 hour. Again, positive for the same reason. Unknown we're asked to find the rate at which the distance between the two is changing with respect to time at a particular moment 2 hours after they started driving. So we want to find the rate at which the distance, and I was using big D for the distance between them. Maybe you want to use a different letter, just dd dt might look weird. Or if you want just, d prime. We want to find this when, or let's just say 2 hours after driving. Okay. So how are these unknowns related to each other? That's not so bad. That's the Pythagorean theorem. Or coming up with our equation or relating our variables. That's an S. We have that f squared, that distance squared, plus n squared is equal to d squared. Now differentiating both sides with respect to time, the derivative of f squared is 2f, but wait, f changes with respect to time. F is the distance that Francisco has traveled. That's changing. The longer it's been, the more distance he's traveled. So chain rule times, either use an f prime or I'm going to do my df dt, plus the derivative of n squared is also 2n, but again, n changes with respect to time, chain rule times n prime, or dn dt, is equal to the derivative of d squared is 2d, but again, d changes with respect to time. That distance between the two of them keeps getting longer and longer the more they've been driving. So chain rule times d prime, or dd dt. Right? And now it's time to go ahead and substitute and solve. Just going to copy this equation. I'm going to go ahead and divide both sides by 2, and then I just have f times df dt plus n times dn dt, or n prime, is equal to d times d prime, dd dt. Divide both sides by 2. Okay? And what did they give us, and what is unknown? They gave us df dt is a positive 60, and dn dt is a positive 25. I'm going to leave the units off for a little bit. That's my 60 miles per hour. This is my 25 miles per hour. And the rate at which the distance between them is changing over time is what I've been asked to find. But the challenge here, so we're going to, just like the problem before, we needed to do a little bit of scratch with our right triangle trig. We're going to need to do a little bit of scratch here too, because I need to know what f is, n is, and d is, what those three distances are respectively at a particular moment after they've driven 2 hours, right? So I'm just going to do my scratch right below. We want to find f, n, and d 2 hours after driving. Okay. Okay, well, F, the distance that Francisco has traveled, F miles, distance is equal to your rate. He's traveling 60 miles for every 1 hour, times time after 2 hours. Oh, if he's traveling 60 miles an hour for 2 hours, he has traveled 120 miles. That's your big F. The distance that he's traveled after 2 hours. Similarly, for N miles, Navraj is traveling 25 miles per hour for your 2 hours. So he's traveled a total of 50 miles. So big N is 50. And then for D, we need to use our Pythagorean theorem. We have F being 120. We have N being 50. And the question is, at that moment in time, what is D? Right? So with my Pythagorean theorem, I know that D squared is equal to 50 squared plus 120 squared. You might recognize a scaling up of a 5, 12, 13 triangle. That's going to be 130. Or we can just go ahead and solve this. But I'm going to just write D is 130 miles. All right, so there's our scratch. There's our little bit of scratch work. Now let's go ahead and solve. So I'm going to take this equation right here. And we're ready to put in our known information. We found out that F was 120. N was 50. And this D right here was 130 miles. Okay, so we've got 120 miles times 60 miles. That gives me 7,200 miles squared. Just multiply those two together. Plus your 50 miles times your 25 miles is 1,250 miles squared is equal to 130 miles times the thing I'm looking for. 130 miles times d dt, or d prime. Okay. So I am going to just divide both sides by 130 miles. We can add these two together. Let's go ahead and do that. All right, so adding these two together gives me 8,450 miles squared, then divided by my 130 miles And we are done. 8,450 divided by 130 is 65 miles per hour. And just one thing on that I'm catching right here, I should have just, if I was going to go with the units, I should have written them the whole time. That 60 isn't just a 60 miles, right? It's a 60 miles per hour. So these are all per 1 hour. Same thing here, 125 miles per hour. So miles times miles is miles squared divided by the 1 hour per hour. Beautiful. And we are done. The rate at which the distance between them is increasing at 65 miles per hour 2 hours after they started driving.